Hello, knowledge seekers! Welcome to Remedial Tutorial Academy. After learning the conjugate of complex number and absolute value, modulus value of complex number, we are ready to learn some properties of modulus of complex number. You can say absolute value of complex number also. Absolute. The first one is, the absolute value of any complex number is equals to the same as, is equals to the conjugate of the complex number, also the absolute value of the conjugate of that also, all right? So let's say j is a complex number, a plus ib. Then the absolute value of j will be definitely the square of the real plus square of the imaginary number, that is b square, all right? Similarly, we know that the conjugate of this j is bar j, which is a plus, the sign get changed, a minus ib. So now the absolute value of the conjugate of this j is also same, the square of the real plus square of the imaginary, and both have the same real part and imaginary part. Just the difference is sign. So here, if you look, absolute value of j and absolute value of bar j means conjugate of j is same. So this is the first properties of the modulus of a complex number. All right? Now the second one is modulus value of any complex number will be 0 only if and only if the complex number is itself 0. 0 complex number, right? Only this is the condition, okay? And the third properties is absolute value of the product of the two conjugate number is equals to the individual product of the absolute value of those two complex number, all right? Let's say you have two complex number, z and w, and if you multiply them, if you find the product of them, and then you'll find out the absolute value of that, then that is same as that is equals to the individual absolute value, the product of the individual absolute value of z and w. All right? Let me give you an example. Let's say z is a plus ib, just like in the previous videos, and w is c plus id. So what I'm going to do now, first I will find out the z times w, okay? So z times w, I will simply multiply a plus ib complex number with c plus id. And that's going to be now AC minus BD plus A times D, all right? So it's I times A plus BC, all right? So this is the multiplication of the two complex number. And now I'm going to find out the absolute of this, absolute value of this, all right? ZW absolute value. So it's just the square of the real part, that is AC minus BD whole square, and square of the imaginary part, all right, that is A plus BC whole square, okay? So let's use the formula A minus B whole square formula, that is A square minus 2AB plus B square. All right, we are now finished with this part. The same formula we're going to use here with the positive sign, that is a plus b whole square formula.
Here, I mean, this whole thing is working as a, and this whole thing is working as a b. So it'll be a squared plus 2ab plus b squared. That is b squared c squared, all right? These all guys are inside the root, okay? Now, I think few things are getting canceled here. 2ACBD, 2ACBD. All right, this is plus and this is minus. So we are left with now a squared c squared plus b squared d squared plus a squared d squared plus b squared c squared. Okay, and in the next step, here is a squared c squared, and here is a squared c squared. So I'm putting those together, a squared c squared and a squared d squared. And I'll write these two at one place, that is b squared d squared plus b squared c squared. And now see the magic what is going to happen. I'm going to take the common here a squared from both sides. So I'll get a squared, and in the bracket, I will get c squared plus d squared. Similarly, from here, I'm taking b squared common, so I will get b squared common, and that will be now c squared d squared. D squared c squared. That's the same thing. D squared c squared, right? And these all guys are inside the root. Now in the next step, see both places we are having c squared d squared, all right? So it is a squared plus b squared and c squared plus d squared inside the root, all right? And further, it is a squared plus b squared. This is multiplication, all right? So it is inside the root, and c squared plus d squared, this is also inside the root. And my dear friend, what is this a squared plus b squared? Look at it here once. Under root a squared plus b squared. That's the absolute value of z, all right? So this is absolute value of z times, now this is absolute value of w. So what do we prove here now? If you take a look properly, see here, the product of the two complex number, and then we find out the absolute value of that. So absolute value of the product of the two complex number is equals to the product of the individual absolute value of those two complex number, all right? And now the next properties we need to understand is the absolute value of the ratio of the two complex number, or say one complex number being divided by another complex number is equals to the ratio of the individual absolute value of those two complex number, all right? Again, let's find out z over w. Z is here a plus ib, and w is here c plus id. So I think you know this directly if you want, but I will do one by one, right? It's a plus ib, and it's c plus id. It's I, right? I is here iota, and I have to multiply and divide by the negative of this. I mean the conjugate of this. So it is a minus id and c minus id. Not a, all right? So now it's simply the multiplication of two complex number in these two cases. So this is going to be now AC minus BD plus I, AD plus BC, all right? Divided by now, this is A plus B, A minus B. So it's going to be C squared plus, now C, it's definitely D squared. And why did I write here plus? Though it should be minus because I times I, it'll be I squared. And that I squared is having the value of minus 1, right? Here in the place of I squared, we use minus 1, no? It is A plus A.
B minus B. So it's I squared, D squared. So D squared is here and I squared is minus 1. So minus 1 turns this into the plus. All right. And further, it's going to be AC minus BD divided by C squared, D squared plus I times AD plus BC divided by C squared, D squared. So this is the J by W. And now we're going to find out the absolute value of J by W. That's going to be the inside the root, the real part square, that is AC minus BD by C square D square complete square, plus the imaginary part square, complete square, AD plus BC by C square plus D square, the complete square. All right, and now quickly let's write the formula of those. A square C square minus 2ACBD plus B square D square. In the both term, if you see properly, we have C square plus D square square, C square plus D square square. So what we're going to do, numerator, we're going to do C square D square complete whole square together. We're taking LCM here, all right? And then here also we can directly use the formula of A square. So a plus bc square, so a square d square, that is a square plus 2ad bc plus b square c square. All right, and these all are inside the root. So here you can cancel this, and then you're left with a square c square, and this is a square d square. So after writing this, I'm writing this one, all right? So it is a square d square, and again here I have b square d square. I write this, then I'll write this b square plus c square, right? It's b square plus c square. Okay, so further, divide by c square plus d square. Okay, and now it is all inside the root. Okay, from here I can take the common a square, so I'll be left with c square plus d square, and again here I'll be left with b, and I can take the common b square from both sides, so I'll get d square plus c square. I'm not writing d square plus c square because this we just did in the previous one, c square d square. All right, so now further, c square d square here also, c square d square here also. So what we getting, c square plus d square we getting common, and we're left with a square plus b square, and divide by c square plus d square all the square. This is this is whole square. So this c square plus d square and 1 will get cancelled, and then we are left with a square plus b square inside the root divided by c square plus d square inside the root. And what is a square plus b square inside the root? That's absolute value of j, and the denominator is the absolute value of w. So we get what we need. Take it up, z by w absolute value is equals to absolute value of j by absolute value of w. Alright, and the next properties of the absolute value is when you multiply a complex number by the conjugate of that, then that's equals to the square of the absolute value. Let me show you how it is. Alright, let's say j and j bar. J is, let's say, a plus ib, and the conjugate of that will be a minus ib definitely. Now this is just like the formula of a plus b, a minus b. Alright, so I'm just using formula a square minus ib all the square. That is a square, I square will be, that is plus, so it's a square b square, and I'm writing here a square plus b square inside the root whole square. And what's that? What is that? That's actually absolute value of j, because under root a square plus b square is absolute value of j, and that's complete square. All right, and the sixth properties of the absolute value I'll write here. Okay, if you have any complex number, let's say j equal to a plus ib, so its conjugate will be definitely a minus ib, and its absolute value will be a square plus b square inside the root. So in this case, the real part of the complex number j is a, and what happens actually that the real part of any complex number is always less than or equals to the absolute value or the moduli of the complex number. All right, how? Let me show you here. This is real part of this, and I said this is less than or equal to the a square plus b square. You know why? If you square both sides now, all right, what you'll get a square is less than or equal to a square plus b square, which is 100% true. So definitely what you can say that a is less than or equal to a square plus b square inside the root. It means the real part of the complex number j is less than or equal to the absolute value or the mod of the complex number. All right. Similarly for the imaginary part, all right, imaginary part of that complex number is always less than or equal to the absolute value of that complex number. All right. In the same way, I'm going to say b is always less than or equal to a square plus b square. All right. You know how it is. If you square it, you'll understand what exactly and how exactly it is. So these were the few very basic and important properties of the modulus of a complex number, or you say absolute value of complex number. Please keep those all properties in mind because it's going to help you a lot of times. Thank you so much for watching. I hope you enjoyed. Please comment down below what are the topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.